Yes, hi guys. So I was just continuing with this question 25th number. We have done 24 questions up to now, and so far as okay, this question is concerned, we were discussing about bypass method as well as substitution method. Okay. So now in this these questions, as I have discussed about, sometimes substitution method is okay being used, and after that bypass method is also used. So in these questions 25th onwards also the same methods, I mean first substitution method I'm just going to use here, and then the bypass method. Okay, so both methods are being used in these questions. That is I've verified number of times. Okay, so now 25th question we are doing. Okay, so in 25th question let me consider for the same process we are continuing bypass method, substitution method as well. So now in this case let under root x equal to t. Okay, let me consider the under root x or x raised to power half is equal to t. Okay, now differentiating it with respect to t, we get this is half x raised to power minus half into dx upon dt is equal to 1, or this is 1 upon under root x. Okay, this is 1 upon under root x into dx is equal to 2 dt. This is differentiation with respect to x. Now if I multiply this by under root x in the denominator and okay, and the denominator and numerator, then what this question turned to. So let me write this under root x into under root x into tan inverse the root x into dx upon root x, no change. Okay, so this I have multiplied by root x and divided by root x. So there is no change because we want to take root x in the denominator. Okay, so that dx upon root x equal to dt, 2 dt. That we will substitute here. Okay, so for that case we have done this as x son of integration. Let me write again tan inverse and root x into dx upon root x. Now let me change this. So under root x equal to t, or x equal to t square from this. So in place of x we have to substitute t square. So let me write here. This will be son of integration. This x is t square, and this dx upon root x is 2 dt, and it is tan inverse t. Okay, and this is twice dt. Let me take 2 out of the sign of integration. This is the final. Now bypass method we have to apply here. I've done nothing but just repeating it. Tan inverse. Now let's using bypass method, using BP method, the integration of it will be okay. Let me take 2 common. Now this is inverse function. Inverse function is first function, and this t square, which is algebraic function, is second function. Because I always use isolate, and I always suggest students when they can decide about which function is taken as first, which is taken as second. The isolate method, through the isolate method, I means inverse function, inverse trigonometric function. This is first function, second function is this. Let me write first function as it is tan inverse t. This is tan inverse t. Okay, as it is into integration of t square into dt minus sign of ddt of tan inverse t into integration of t square into dt whole dt. This is, we know what is bypass method. This is bypass method we are using here. Finally we get tan inverse t as it is. T square means tq upon 3 integration minus sign here Now differentiation of this is 1 plus t square. Because we are in differentiating it with respect to t. Simply 1 upon 1 plus t square it will be. And this will be tq upon 3 into dt. Okay, so now if I let me divide it tq by 1 plus t square, then it can be converted into two parts. There will be a quotient here plus remainder divided by this value, so that can be done in that case. Now this is, do that here, 2 into, or let me take 2 by 3 into tan inverse t into tq minus sign. This is 2 by 3 again. Let me write them separately. Okay, this bracket is, let me take like this, and this is also 2 by 3, 2 upon 3 is this, and this is nothing but tq upon 1 plus t square into dt. Now if I divide, let me divide tq by 1 plus t square, what it will be? Simple, if I multiply by t square, this will be tq plus t minus minus, this is minus t, cancel out, so it will be minus t upon, okay, so this is 1 plus t square means t, this will be, let me write here, this is 2 upon 3, okay, tq into tan inverse t minus sign 2 upon 3, first is t times, t is quotient, t into dt, let me separate that, this minus sign and this minus sign will be positive, plus sign 2 upon 3, t upon 1 plus t square into dt. Now this we will separate, or let me do it again considering that 1 plus t square equal to u, okay, in the last one, and this is up to this, let me integrate, this is 2 upon 3 tq into tan inverse t, first part, this is minus 2 upon 3 into t square upon 2, this will cancel out, and in this we will get, this is 2 upon 3, now let me take, again let, or substitute, this is we are substituting, again let me substitute, again substituting, or on substitution, again on substitution, let here, on substitution, 1 plus t square equal to u, let me take, therefore integrating with respect to u here, should be twice t into dt equal to du, let me get directly, t dt therefore equal to du upon 2. So this can be converted as 2 upon 3 sum of integration, this is du upon dt, or sorry, du upon 2, that means into 1 upon 2, this is 1 u only, okay, plus constant of integration that we will write next. Finally we get 2 upon 3 into tq into tan inverse t, this is minus 1 upon 3 t square, this 2 to cancel out, this is plus 1.3, okay, plus 1.3, and this is log of u. First u is to be plus constant of integration. Now let me write here the answers. Finally let me write the answer here, which will be after converting t and everything. Okay, so x equal to t square, and before that 1 plus t square we substituted again u in this case, that will also be there, 1 plus t square equal to u. Finally answer will be this 2 upon 3 t square. T square means x, and this is t into, it will be, therefore t is equal to 1.2x, okay, and tq equal to therefore 1.2 3 by 2, it will be 2 by 3, or if I find out t is x raised power half, so tq equal to x raised power 3 by 2, right, this is x raised power 3 by 2 into tan inverse t, that means the root x okay, minus 1.3 t square. T square means x only, okay, plus 1.3 log of u. First let me write 1 plus t square, because u is equal to 1 plus t square here, log of u, u means 1 plus t square plus constant integration, but still answer is not in t. This is to be converted into x, so that will be 1.3 x plus 1.3 log of 1 plus t, sorry, 1 plus t square means x, 1 plus x plus constant of integration. This is the final answer here. This is answer of question number 20. Okay, question number 20 is finally solved. 1 plus t square, we have divided t cube by 1 plus t square, then we got this t minus t upon that value. So that was okay. This is the answer. So we have substitute 2 times be substitution by the first in terms of t, x converted to t, then t was further converted to, or substituted in terms of u. Okay, then finally answer was obtained. Then this is substitution method, as well as by-parts method and substitution. Both are used in this case. Okay, so this is the process of solving the questions of this kind. When substitution method as well as by-parts method, and first by-part, then substitution, or substitution first, then by-parts. That is the process of solving these questions. Now let me take the next question. This is 25th question. Okay, I always write, because this is very important for solving the questions by by-parts method. Highlight must be remembered. That is my just suggestion for the students. Okay, or for the people who are coming to know about this. Now let me take the next question. This is 26th question. Question number 26, sign of integration. This is x square into tan inverse. This is okay, tan inverse x, right, divided by 1 plus x square into dt. Now this is, here it was 1 plus x whole square, sorry, this one was unroot x and that. Now this is directly given to us. Now let's consider tan inverse x equal to t completely. So let's tan inverse x equal to t. Substitution. Let's do substitution. On substitution, let me write here on substitution. This is first substitution. The tan inverse x equal to t. Differentiating it with respect to t. Differentiating it with respect to t, we get this is 1 upon 1 plus x square into dx upon dt is equal to 1, or 1 plus 1 x square into dx equal to dt. Okay, so if we substitute here, that will be sign of integration. And what is x square here? From this, let me write x equal to tan t, or x square equal to tan square t. This is or. Because tan was x equal to t, or x equal to tan t. Therefore, x square equal to tan square t. Let's put here x square is tan square t. Into this is tan inverse t means t be adjunct. This is only t, tan inverse t. Okay, into dt. Because dx 1 upon 1 plus x square is equal to dt. Okay. Now let us integrate this. So further, let me change it into sec square t minus 1 into t into dt. Okay. It will be converted as sec square t into t into dt minus sign into t into dt. This is t into dt minus sign, and this is sec square t into dt. Okay, that is what we have obtained. Now let me integrate this by parts method using by parts method. the first one, the first part, using PP method in part 1. This part 1. Okay, so we using now this is for integration, for differentiation, trigonometric function, algebraic function. So first algebraic function, then trigonometric function. So I let a algebraic function first. This is first as it is integration of secant square t dt minus sin d dt of t differentiation integration of secant square t into dt whole dt. This is equal to t into secant square t is 10t. We know what integration of secant square t is 10t minus sin. Now this is 1 into secant square t is 10t only into dt. Okay, sorry, this is also left. This is minus t square upon plus constant of integration. This is t square upon 2. This was left over. I've written down now. This is minus t square upon 2 plus constant of integration. Now this is t into 10t minus 10t integration of 10t. You know that minus log cos x or cos t, or it will be log secant t. It will be log of, if I write positive minus cos, then minus plus, this is cos of t minus t square upon 2 is constant of integration. Now let's substitute the value of this cos t is equal to what in terms of x. 10t is equal to x, let me write here. This is right angle triangle, right angle, and this is, let me take angle t. Here it is x. 10t is this perpendicular upon base, this is hypotenuse. It will be under root 1 plus x square. Therefore, cos t is equal to 1 upon under root 1 plus x square. From this right angle triangle, this is ABC. Okay, so cos theta is this upon this, base upon perpendicular. So 1 upon under root 1 plus x square it will be. So from this right angle triangle, from Pythagoras from this we know what 1 plus x cos theta is base upon hypotenuse. This is perpendicular base hypotenuse. Okay, now come to the point. So cos t will substitute that value, and t square is tan inverse. T square is tan inverse x whole square. All right, and 10t is x here. T is again tan inverse x. This is x into tan inverse x. T is tan inverse x. 10t is x. This is x into tan inverse x plus sin log of cos t. Cos t is 1 upon under root 1 plus x square. Okay, this will be, I'll write down this further, minus t square. T square is tan inverse x whole square upon 2 plus constant of integration equal to x into tan inverse x. Okay, this is plus log 1 is 0, and then minus sign it will be minus log of, let me take half here. This power half will come before, it will be log of 1 plus x square. Okay, because this is log m upon n, that means log m minus log n. Denominator is with negative sign, minus log of denominator. Now log of denominator means half power, log m raised to power n means n log n. Power will come before, minus half into minus sign, because this is denominator. Log m means log 1 minus log this. Log this means log half of 1 plus x square. That means half log of x 1 plus x square. Power is half. That power comes before. Okay, and log 1 is 0. That 0 we have not substituted here. Finally, this is the answer. Minus tan inverse x whole square upon 2 plus constant of integration. So this is x into tan inverse x minus half log 1 plus x square minus tan inverse x whole square upon 2. This is whole square. This is the final answer. So question number 26th. Now we have done 26th question. Now let's talk about 27th question. Now question number 27. Let's say question number 26th. Let's talk about question number 26th. We have done now 27. Question number 27. Question number 27. Sign of integration x into tan inverse x into tan inverse x upon whole 3/2 power into dx. Okay. Now this can be written as upon 1 plus x square whole under root into 1 plus x square. This is 3/2 power, that means 1.5 power. This is half power, this is 1 power. Can be separated like this into dx. Now let us take, okay, tan inverse x equal to t. Therefore, differentiating it with respect to t, we get 1 upon 1 plus x square into dx equal to dt. Okay, so from this x equal to tan t, this implies that x equal to tan of t. From this x equal to tan t, that is also there. Let's convert this whole value, substituting these two values and x equal to tan t in this equation. It will be x means tan t. This is tan t into tan inverse x is t into t into dt. This upon this is tan dt divided by, this is 1 plus tan square t. Okay, so we will get tan t into t, let me write t first, t into tan t into dt. So it will be second t. Why? Because 1 plus tan square t equal to tan t, tan square t. This is 1 plus tan square theta. We know that equal to second square theta. Therefore, square root of this equal to second theta. Since therefore this value, we have substituted this value be 1 plus tan theta equal to second square theta. This one. Therefore, square root of this will be second theta only. We have substituted sec theta, sec t. Okay. Now let me convert this again. This is t into, this is sin t upon cos t. This is 1 upon cos t. Cos t cancel out into t. This is nothing but t into sin t. T into sin t integration. Now we can apply VP method. Now using VP method, integration of this will be t as it is, because this is auxiliary function. Trigonometric function is second function. T into integration of sin t. VP method is first function, this is second function. Algebraic function, trigonometric function. I lat, L-A-A-A-T, L-A-T. Okay, I, okay, I lat, I-L-A-T-E. So A-T, okay, A first, algebraic function first, and trigonometric function second. This is what first function as it is, integration of second. Minus sin ddt of t into integration of sin t into dt whole dt, t into minus cos t minus sign, this is 1 into, now plus here, this is cos t 1 dt. Okay, so this will be, we write here, this is minus t cos t plus it will be sin t integration, the constant of integration. Integration of cos t is sin t positive, but here it is minus t into cos t because integration of sin t is negative cos t that we have done. Finally, let me substitute the values. So here we consider, okay, tan inverse t was that value. Okay, so x was tan t. So let me consider tan t equal to xt. Cos t sin t is what? That we just calculated here. Let me take the right angle triangle, this A, B, C. And if this is t angle, then sin t, tan t is this upon this is x upon 1. Okay, this is under root 1 plus x square by Pythagoras theorem. Sum of the square of these two sides equal to square of this side, third side. This is side opposite to right angle, that means hypotenuse. The square of hypotenuse equal to square of the sum of these two sides, sum of the squares of these two sides. Therefore, cos t equal to, this implies that cos t equal to 1 upon under root 1 plus x square, and sin t is equal to x upon under root 1 plus x square. Okay, so these two values are there. Let me substitute here. Finally, minus t means tan inverse x into cos t. Now cos t is 1 upon, that means upon under root 1 plus x square. Okay, then plus sin t is x upon under root 1 plus x square. Okay, this is sin t. T into sin t, t means sin tan inverse x, and divided by 1 upon, or multiplied by 1 upon, or divided by under root 1 plus x square. Cos t means 1 upon this, to multiply this. Okay, now this is x upon sin t is x upon 1 plus x square, plus constant of integration. This is the answer. Okay, so this is the answer. Question number 27 we have. Okay, now question number 27th we have done. Now 28th question. What is question number 28? Let's talk about 28th question. This is log of a square plus x square into dx. Okay, so in this case we can consider, because this logarithm function is I, that the first function, and 1 let me consider in multiplication of this as the second function. Okay, so let me consider 1 in multiplication of this as the second function. So, okay, so let me, to integrate this, let me write here. To integrate this, to integrate it with rest by, or using BP method or by parts method. Let us consider one or unity as the second function, of it. So it will be log of a square plus x square into 1 into ds. Okay, this we have to integrate by using BP method, by parts method. So it will be, okay, log of that a square plus x square, first function as it is, integration of 1 into dx minus sign. Now ddx of log of a square plus x square into integration of 1 into dx whole dx. Okay, so this is this value. Now let us consider this. This is nothing but x. So x into log of a square plus x square minus sine. Now differentiation of this is first 1 upon a square plus x square. Again differentiating this whole value because this is not x simply. By chain rule or by function of a function method, differentiation of a square plus x square, it will be 0 plus twice x. It will be twice x in the numerator. Let me write here. This is twice x into integration of x is x 1. Integration of 1 is x into ds. It is nothing but x square. Twice x square. Let me write here x into log of a square plus x square. If I take 2 common out, it will be x square. If I add plus a square minus a square, it will change. So this is a square plus x square, okay, into ds, the constant. It will be x into log of a square plus x square minus sine, this is twice into x square plus a square or a square plus x square upon this same value. It will be only 1 into dx, and this minus minus plus twice a square into 2 into a square into 1 upon a square plus x square into dx. Now this integration we know. This is 1 upon a tan inverse x upon a. Directly we can substitute the value, or further we substitute that x equal to a tan theta, okay, or tan t. If I substitute a into tan theta, then differentiation will give us a into secant square theta. In the denominator, secant square theta will be obtained. A square will be taken common. A upon a square means 1 upon a. Okay, and that is secant square theta upon secant theta cancelled out. Only ds, integration of that will be okay, x only. Okay, so that in this case theta, it will be theta only. Value of theta will be tan inverse at x upon a. Okay, so that is the formula. Okay, or we directly substitute the value. Let me substitute value directly. This is x into log of a square plus x square minus sine twice into x into plus 2a square upon